Geometry, lesson 26. We're going to be covering two lessons today, lesson 26 and 27. I don't know if the board is shaky because of the construction or what's going on there. It's going to drive me nuts today. All right, we're going to be talking about central angles and arc measures. This is coming back to properties of circles. An arc, and we want to make sure we're paying attention to some of the labels in here, and hopefully we understand them. An arc is a part of a circle consisting of 2 points on the circle. So whenever they say on the circle, they don't mean inside the circle. They mean as points on the outside. So I don't know if my board's been unplugged. Let's see if we can plug that back in and get some functionality back. Consisting of 2 points on the circle. Let's try. Nope, not yet. And all the points on the circle between them. So when two arcs on a circle share exactly one endpoint, they're called adjacent arcs. So we can have more than one arc right next to each other. This would be like adjacent angles, right? They're going to be arcs that share a common endpoint. Okay, let's see. So endpoints in this case would be here and here. All right, so if I had an adjacent arc, okay, that would be like these two. Okay, those are adjacent to each other. They share exactly one endpoint. Okay, an angle whose vertex is at the center of a circle is called the central angle. So if this is the center, then this angle is a central angle. Okay, if this is at the center, then this is a central angle. Any angle that is stemming from the center of the circle, okay, that's coming out there. Can we put the gum away so I don't have to see that? That'd be great. Perfect. Okay. Those are all central angles. Okay, does that make sense? The reason that's going to be important is that not all angles that occur from the inside of a circle from the center are central angles, and central angles have specific properties to them that other angles don't have. For instance, central angles and inscribed angles are different. Okay, let's see. So the diagram below shows a central angle that intercepts an arc on the circle. So if we kind of come back to this angle intercepts this arc. Okay. Now, the reason that that's important is because the relationship of a central angle to the intercepted arc is that they will have exactly the same degrees. Okay? So if my central angle is 45 degrees, then my intercepted arc is 45 degrees, but only if that is a central angle. Okay? All right, so dealing with arcs of a circle, we have what is called a minor arc. So going back a page, okay, we're referring to this right here, whether or not it's a major or minor arc. And a minor arc is smaller than half of a circle. So that arc that we looked at, this arc right here, is that major or minor? Minor, because it's less than what? Which is how many degrees? 180 degrees. So a minor arc is any arc that's less than 180 degrees. Okay? The measure of a minor arc is the same as the measure of its central angle. We just discussed that. The measure of a minor arc is going to be greater than 0, but it has to be less than 180. Not even equal to 180. It has to be less. Okay? All minor arcs are named using 2 endpoints of the arc. Okay? So whatever those 2 letters are. Okay? Then we have what is called a major arc, okay, which is larger than half a circle. We could go back a page and we could draw a major arc. Okay, let's say we got this point here and we got this point here, and we're going to go from here to here. That's greater than 180 degrees. This is a major arc. But because we could confuse it with going the other way around and making a minor arc, we are going to include a third point that exists between those two. Okay? So the measure of a major arc is the difference of 360 degrees in the measure of the associated minor arc. The measure of a major arc must be greater than 180 degrees but less than 360. Less than 360 because that's the max number of degrees in a circle. All major arcs are named using the two endpoints of the arc and a point on the circle between those two endpoints. So you'll be able to see based upon labeling if they're talking about a major arc or a minor arc, because they might say something like, well, here we'd say, what is the measure of arc AB? I know by how that's written, because they're only including 2 points, that this has to be a minor arc, correct? Okay. But if we said, what is the measure of arc ABC, I know that that's got to be a major arc because it's including 3 points. All right, anybody have any issues with the difference between minor and major arcs? Okay. Then we have a semicircle. Okay, so its angle is going to be a diameter. Semicircle is an arc equal to half the circle. The measure of the semicircle is always equal to 180 degrees. Like major arcs, semicircles can be named with the two endpoints of the semicircle and a point on the circle between the endpoints, because we want to know which direction, which semicircle are we talking about. Because in any given circle, if I've got a diameter, how many semicircles do I have? Okay, let me try to be more specific here. All right, so I've got a circle there. This is my angle. It's going through the center, right? Let's call these endpoints A and C. Okay, how many semicircles are there? 2. All right, if I want to be more specific about which one I want, I will put a point there. Okay, now do you know which semicircle if I said measure of arc ABC? You know which side, right? Versus if I said measure of arc ADC, now you know the difference between those two semicircles based upon how I would label those, right? You know what we would be looking for or asking about. Okay? So we have, just like how in, like lesson 2, 3, something like that, we had the segment addition postulate, right? 2 segments added up will make a larger or whole segment. Then, like by lesson 3, I think we had like the angle addition postulate, right? If we have 2 adjacent angles, we can add them up and come up with a larger angle, correct? This is no different. Arc addition postulate is just another way, and it's really very similar to the angle addition postulate. It's just taking place inside of a circle. Okay? So don't overcomplicate this. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Now, whenever they say arc, they're referring to like from Q to R and from R to S. Okay? And we measure arcs in degrees. So the arc addition postulate says that if 2 arcs are adjacent, the sum of their measures is equal to the measure of the larger arc that they form. So we would want to know what is arc QRS. We would find that by taking arc QR, adding arc RS to it, and that's going to give me arc QRS. Does that make sense? Okay. Hopefully not too complicated there. Okay. Okay. Let's see. 2 arcs that are in the same circle or in congruent circles that have the same measure are called congruent arcs. Right? 2 things that are equal are also considered congruent. So if we drew a circle up here, right, and I said that these were, this is 45 degrees and this is 45 degrees. Those 2 arcs, whatever they are, whatever I labeled them, would be congruent to each other. Okay? Lesson 27, I feel like we've talked about this kind of at length so far, which is talking about 2-column proofs, which is not our most favorite thing to talk about, right? Okay. In a proof, we're using deductive reasoning. They start off at least fairly simple, just basic properties that we would use, right? Like, so segment addition postulate, properties of equality, those types of things. So the addition property of equality, subtraction property of equality, things like the transitive property, the symmetric property, reflexive property, all those types of things are getting used. So we want to develop a logical argument from given information to prove a conclusion. So proofs in geometry are done step by step. Each step has to have a justification. We have to have a reason for why we're doing something, okay, which is usually a postulate, theorem, or property of equality, okay. Let's see, these justifications can include given information, so whatever they hand me right off the beginning. I want to use as much of the given information as possible. Any definitions, postulates, theorems, properties, as what we've seen in two-column proofs in this lesson. They have a format that's composed of 5 parts. Okay, they're not especially difficult, but you're going to have a given statement. So whenever they give you the question, they're going to give you a given statement. That's going to be the first thing that you want to put in your proof. On the left-hand side, you're going to write down the information that they gave you. Your justification on the right-hand side of the two-column proof is the word given. Okay? Then we have to prove our statement. So the statement indicating what is to be proved. So look at, all right, this is what they've given me. This is what they're asking me to get to. Okay? Just like in the questions that we're getting on our test, you have to figure out what is it that they're looking for, because oftentimes it's not solve for x, right? Sometimes it's what is measure of angle 1, which includes solving for x, but it doesn't stop there. Okay, so I want to look at what they're asking me to prove. Then I have a diagram, so a sketch that summarizes the provided information. Sometimes you'll need to draw a sketch yourself based upon the given information. And we've seen this in questions, not necessarily as a two-column proof, but have we ever had a question that gave us information about a triangle but didn't give us a picture of a triangle, right? Talked about a line segment but didn't draw a line segment. So we should be used to, by now, actually drawing pictures whenever they give me information to put it together for ourselves. So we may have to sketch a diagram. You don't always have to, but it can help. Statements, the specific steps that are written in the left-hand column. So statements on the left, reasons or justifications on the right. Okay, those are my postulates, theorems, definitions, properties. They're in that right-hand column. They need to be one-to-one. So if you've got a statement, you need a reason. Okay? All right, and that's what we have here. So let's go ahead and get into some questions. By far, the lesson 26 stuff is going to be the easier stuff, right? A major arc has a measure of 2x plus 60. The corresponding minor arc has a measure of 3x minus 50. If I have a corresponding minor arc to a major arc, what is their sum total going to be? 360 degrees. Okay. All right, so we're going to have a major arc, which is 2x plus 60, plus 3x minus 50 equals 360, correct? Okay, what's the next step, Jose? You can't see? Would it help at all to move closer? So what are we doing there? Combine like terms. So 2x plus 3x is 5x. Okay, so we're combining like terms. We got 5x. Jordan, thank you for helping out there. Can you go ahead and tell me what we would do next?
After you do the x, you got to do the 60 and 50.
Okay, so what does that come out to? 10, right? Because it's 60 minus 50 gives me a positive 10. It's 360. Chandler, what would you do after that? Subtract 10 from both sides, right? Because I need 10 to cancel out on the left. All right, so I've got 5x equals what, Chandler? 350. Okay, Katie, what do you do after that? Divide by 5 on both sides. We get x equals what, Maddie? 350 divided by 5. $70. Okay, now if we're not careful, right, we're going to go ahead, we see that question on a test, we're going to circle that right there because D shows me 70, right? Okay. Is it right? Do you? No, I don't. Why not? Because I led you to believe that it needed to be plugged back in, but you didn't read the question. It says find x. So in this case, am I done at 70? Yes. Okay? But I always want you to be reading the question. Okay? Determine where it is that I stop. Okay? Okay? Let's look at our next one here. 2. An arc of a circle has an arc measure of 82 degrees. If the circle has a radius of 11.4 units, what's the length of the arc? Okay, so this gets into a question that is not addressed in your book in this lesson. Okay? Some of you Algebra 3 people might know this formula, but this is one that you need to write down, need to put it in your notes. So are we listening? Okay? This is how we find the measure of an arc. Okay, so arc measure equals, and because arc measure is based upon the distance around that circle, right? Except it's not the whole distance around the circle, it's just part of the distance. Okay, arc measure, okay, or arc length, sorry, let's do this, arc length. Okay, they're asking for the length. Okay, arc length is 2 pi r times the measure in degrees over 360 degrees.
Isn't that how you mark the circles with the boxes in?
No.
Oh, that's just
No. Yeah. No. So how do I find arc length? We take the circumference and we multiply it by the fraction of the degree of the arc over 360. Okay, so we're multiplying it by a fraction. Okay, later on we'll talk about the sector, which is the area of like an angle formed inside, which our central angle, that area. It's very, very similar to this, but arc length equals 2 pi r times the measure over 360. Do we have this formula written down? Yes or no? I don't know that we do, because it's not in your book.
I typed it in.
You typed it in? Where'd you type it in at? Okay. All right, so let's take this. Okay, we've got this down, we can look at it, okay, after I erase it? Good. Okay. So, we want to know our measure. Okay, what's the next thing I'm going to write in based upon the information that they've given me? 2. Okay? Pi. 11.4 times 82 over 360. Okay? Two pi 11.4. And I'm going to check. Ooh, see, that's where we want to check, because if I'm going to do this in my calculator, I need it in degree mode. Okay, 82 divided by 360. And I get 16.32 C. Okay? Does that make sense? We understand what we're doing there? Okay. In area of a sector, the area of a sector formula, the only thing that changes that instead of having their circumference formula out front of my measure over 360, I'm going to use the area formula, so pi r squared times measure over 360. That's the only difference. Okay? Number 3. Okay? Circle graph shows the results of a survey by a bakery to determine which of its new products its customers preferred most. We want to find the central angle measure, so we're looking for something in degree form of the sector that shows the percent of people who prefer pi. If necessary, round your answer to the nearest tenth. So pi is 26% of the pie, correct? Okay. All right, so basically what we're looking for is 0.26 of what? 26% of what? It will have 360 because 360 is the whole, right? So what's 0.26 times 360? Because we're trying to convert to degrees, which is why we use 360. 93.6. Okay. You probably could have looked at it also as 26 over 100 equals x over 360. Okay, you could have solved it like that as well. Okay, it would get you the same thing. Okay, what is arc? What is the measure of arc MN? What is the measure of arc MN? What do you think, Marcos? Yep, arc MN. 105 degrees. That is absolutely right. Can you tell me why? Because my angle MCN is what type of angle? Nope. It's not obtuse. Nope. In order for it to be congruent, it have to be congruent to something. It's the only angle up there. Go to your notes for today. It's a central angle, right? And anytime I have a central angle, right, an angle whose vertex is the center of the circle, the central angle and the intercepted arc are going to be congruent, right? So that's going to make that 105 degrees. Really no math to show there, okay? You want to see these types of questions as much as possible, right? Okay, but here's the thing about questions like that is that if you don't know that, it doesn't matter how easy the question is, you'll still get it wrong because you don't know it. You see how the more that you know, the easier stuff gets, all right? But if we get really lazy about things, then the easy questions become hard. Okay? Okay, let's look through here. All right, this is the type of question you would see on a test. Okay? What is the measure of arc CFB? Okay, so what I wanted to look at is what are we actually talking about here? There's CFB. I want to know what is that measure in degrees. Now, what's nice about it is that this is a central angle, at least if I look at CPB, right? And part of it is already, go ahead.
Okay, since you're trying to find CPB, right?
CPB is what I want to find.
So wouldn't 50 be corresponding to FPB?
You're saying wouldn't 50 correspond to FPB? No. No, you're using the wrong term. It's not corresponding. It would be vertical, right? So you're looking for vertical angles, but 50 is vertical to something. It's just not vertical to FPB. It's vertical to BPD. That's what it's vertical to. So BPD is 50 degrees, and we can use that to solve. Not exactly. Okay, so look at this, right? This line right here is what? How many degrees? 180 degrees. Out of those 180 degrees, I'm aware of 90 degrees and 50 degrees. What I don't know is what that angle right there is, right? All right, so out of the 180, I know for sure 140 of them, correct? All right? So 180 minus 140 leaves me how many degrees left for that unknown angle? 40. Okay, so now I know that this is 40. Okay? Take 40 and add 90 to it. I get 130 degrees. Okay, does that make sense? And that's my arc because that's a central angle and it's going to measure the same thing, right? So that's how I'd get 130 degrees. But it's not the only way to get 130 degrees. Let me show you something else about this question. Okay? That this is also 180 degrees, right? And it'd help if my board wasn't shaking, I'd get a better line off of it. Okay? Something like that. Okay? So here, that's 180 degrees, but I still only want this, correct? All right? So what would I subtract out of it? If my red line is 180, but I have how many degrees too many? I have 50 degrees too many because I really don't want CPA, right? So if I subtract CPA out of that 180, I'm left with 130 degrees. Right? And I didn't even have to solve for FPB because I knew it was part of that straight line. Okay? All I had to do was take this part out of the 180. Okay, so you see how the more I know, sometimes the less math I need to do, right? And 130 is still correct either way, right? Okay. Let's see. Let's try to get at least one proof type of thing done. Identify the property that justifies the statement. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, what allows me to understand so that segment AB is congruent to segment EF? This is the same principle is if A equals B and B equals C, then A equals C. Right? What do we call that? Is it reflexive? Let's eliminate what it's not. No. Symmetric property is if A equals B, then B equals A. Right? And symmetric property is just where I can flip two things. Okay? Reflexive property is where something is just equal to itself. Are we looking at something that's just equal to itself? No. So it's not symmetric, it's not reflexive. Okay? So it has to be transitive. Think of transitive like transportation, right? I'm going from one place to someplace else, okay? And a lot of times to get from here to where I want to go, I have to go through something else, okay? Think of transitive as transportation, okay? I don't know if that helps you or not. It's not a perfect illustration. Hopefully helps you out a little bit. All right, let's see if we have any more. All right, let's look at least this one, and then I'll let you loose. We want to fill in the blanks to complete this two-column proof. My given is that EG, okay, EG is congruent to FH. Those two things are equal to each other, okay? So that's what they start off with. EG is equal to FH. Now, we want to look through the completed proof and see what they've done to get from step to step. Can I kind of get some eyes up here? All right. So notice here they kept EG. So they went from EG to EG. They didn't change anything about EG, but they did something with FH. They went from FH to EF plus FG. Okay? So EF plus FG. What did they do there? How did they go from FH to being EF plus FG? They factored it out. Kind of, but what would we call EF plus FG? Are they angles?
No, they're actually.
They're line segments, right? Are we subtracting? I mean, let's look.
Well, what's an angle addition function?
Yeah, okay, that's probably wrong. We can probably go ahead and throw that out. Yeah, no, it doesn't make sense. Could it be substitution property? Why not? I've substituted EF plus FG in for FH. Are those two things equal to each other? What other options do I have? For number one? Yeah, that would probably work. Okay. Yeah, the segment addition postulate probably works better than just substitution. Okay? So, segment addition. Because that's what I'm actually doing. These are segments, I'm adding them up. Okay? Okay? Let's see. Then they say FH plus FG. Let's see. Hold on. Let me erase this because it's kind of all been moved. FH, which is this guy, is made up of FG plus GH. All right. Well, that's at least, didn't they do the exact same thing that we did up here? Right? And they used the segment addition postulate. So that should give me confidence that we did the right thing with the segment addition postulate, correct? Okay, let's look at the next thing. EF plus FG equals FG plus GH. Okay? So basically what they're saying is that instead of EG plus FH, we're going to take these parts that we've essentially substituted and keep them as substituted on both sides. Okay, because we knew that these things were equal to each other. Okay? So at this point, could we use the substitution property? Yeah, we're using substitution. Okay? And then you'll notice from here, now the question's been answered, but how do we get from EF plus FG to FG plus GH? What exists on both sides? FG. So if I subtract, they'll cancel out, and I'll be left with EF equals EF equals GH, and that's what they wanted me to prove to begin with. Okay, I have to end with what they wanted me to prove. That should be the last statement in every proof is what they ask me to prove for. Okay? All right, a lot of these are just kind of fill in a blank type things. You're not really writing a lot of full two-column proofs just yet. So we'll stop there. I'll let you guys work for the next 2 minutes.